All right. So one thing I realized last class is the videos are okay that get posted to YouTube. If for whatever reason, if you're on the Zoom and it ever looks like things are like flipped backwards, let me know. That mirror my image setting, I think it had it defaulted on last class, and so I've got it turned off now, so it should be okay. But if ever anything's ever looking kind of backwards to you, make sure you let me know. So today, where did we leave off, right? We started talking about marginal production and kind of marginal costs, relating this idea that, as the marginal production of our kind of players or workers falls, to get one more additional unit of output or one more additional win, it was going to cost us increasingly more money, right? So we had this increasing marginal costs for the number of wins, okay? So we're going to kind of come back to that in a second. But first, we're going to start to think about some of the differences that might exist in markets, okay? So typically, when we have a perfectly competitive market, right, we mentioned a little bit of this, I think, last week, where nobody has any influence over the price, right? No one buyer, no one consumer or one producer, one seller has any influence over the price, right? So we say firms are kind of price takers. If they were to charge a higher price, there's always going to be another firm out there that, or enough firms out there to kind of undercut that price. And so consumers would just buy from them, right? So this idea is they don't have any influence over the price. Therefore, when you sell a unit, you're kind of subject to whatever the price is on the market at that, in your industry or at that point in time. So we'll think about kind of maximizing our profits. We'll continue to sell additional quantities of a good up until the point where the marginal revenue or the additional revenue of selling that unit will kind of be greater than the marginal cost of supplying that unit, right? And then we stop at that point where they're equal, right? So just kind of a review of markets, and then we'll think about how this kind of changes things in the ticket market. Oops, I wanted to go to advanced. Review some stuff about monopolies in the slides. So let's see, we think about quantity kind of being here on our x-axis, right? We can think about kind of our y-axis representing dollar amounts, right? So firms will face, and typically you've probably seen them kind of drawn like this, where we might additionally see kind of gains from specialization. For the most part, we're not going to be concerned with that part of the marginal cost curve. So if you really wanted to, you can kind of just draw this as a straight line if that's just a little bit more simplistic. One thing you might kind of remember, or you have things like average total cost curves. We'll review this when it becomes a little bit more important to some of the topics we're talking about. But for right now, what we're thinking about is, right, whatever the price of the good that's being sold, and this is just kind of a general kind of framework, whatever product's being sold, whatever price it takes on the market, and right, we know that that equilibrium price would be, if we're thinking about this is for one individual firm, so we can think about kind of this is a firm's cost structure, but the entire market for that good is what determines that price. So you might think about we have our supply and demand curves here. You can identify the equilibrium. So whatever that equilibrium price is and quantity on the market, right? Firms have to take that equilibrium price as what they can sell that good for, right? So that will be their additional revenue, their marginal revenue from each unit sold will be whatever that equilibrium price is, right? You think if I'm selling, we could go through any example. If I'm selling, these markers, right? Whatever the equilibrium price for a marker is, that's what I have to sell as a firm in that industry. And so every single marker I sell is going to bring me the exact same amount of additional revenue, okay? So we would say here the optimal quantity, right, is going to be where the marginal cost of that last unit provided is equal to its marginal revenue. So we can identify kind of the equilibrium quantity for that firm. So that's kind of the idea, just kind of a quick little refresher of a perfectly competitive market, how the firm's cost structure would look. Now, what happens instead if we've got a monopoly, right? So we'll review the kind of general implications, and then we'll kind of move towards thinking about monopolies and things like ticket markets. Okay? So here we had a difference between kind of what was determining the equilibrium price in the market and how individual firms were making their production decisions. Okay? Everybody okay with that? Good to move on? Okay. So, let me make sure there's nothing. All right. Slightly different is, I shouldn't say slightly, quite a bit. Let's say we're thinking about a market where we don't have a perfectly competitive market, but instead one firm kind of rules all, right? So if one firm rules all, right, they'll still face this marginal cost curve. However, right, there will be some demand curve as well. Now we said we can think of supply as a marginal cost curve. And we're looking at just a, like a perfectly competitive market, like here. Those marginal costs might be coming from different producers or different sellers. Well, here, we only have one seller, one producer, so that producer's marginal cost curve is essentially the same thing as the supply curve for that market, because they're the only company willing to provide anything or selling to that market, in that market. So we can think of, we've got this supply curve, which is really just whatever that one firm's marginal cost curve is. Okay? And then we have our kind of demand for that product, right? If this firm, right, is only going to be selling this product for one price, what ends up being true, I'll do a review of this in just a second, is that our marginal revenue curve is twice as steep, right? This is if we keep demand linear, it's always twice as steep. It'd be a little bit more math to figure out what that marginal revenue curve is if demand wasn't linear. But for the sake of all the examples that we'll look at, we'll kind of treat demand as linear anytime we have to do any mathematical calculations. So the point at which the monopoly decides to produce, it's not like in a perfectly competitive market where it's the quantity in that market will be where supply is equal to demand, right? Because that would actually not provide the highest profits for the monopoly. We can actually determine the highest profits are actually going to be where marginal cost is equal to marginal revenue, right? This is going to be the same, for any decision that we're trying to make. Whenever we're trying to determine what the optimal quantity or the optimal number of games or whatever it is to provide, I think today we might even get to the optimal number of teams in a league. It's always going to be based off of where the marginal revenue is equal to the marginal cost, or the marginal benefit is equal to the marginal cost, right? We'll continue to produce up into that point. So that would be here. So the monopolist wants to choose the quantity where marginal cost is equal to the marginal revenue. But the nice thing for the monopolist is they know at that quantity, people are willing to pay. Remember, demand is marginal benefit. So people would be willing to pay up to whatever that value is on the demand curve at that quantity. So the price that the monopolist sets, because they know people would be willing to pay it, is whatever point we'd be at on the demand curve at that optimal quantity the monopolist chose. Okay? So, we've got quite a price that's quite a bit higher than, we want to think about it this way, if I'm a monopolist and I produce this quantity, sell this quantity to the market, the marginal cost of that last kind of unit would be somewhere out here. So you can think about all the, the marginal cost to provide each one of these units is much higher kind of than the price there. So we can kind of think about this as like, this is a benefit to the monopolist, right? They're selling things for much, much higher than what it's costing them. See if I want to see anything else here before we kind of keep going. Are there any questions on this before we keep moving? Okay. I think I have a slide on this, but as long as we got this, we might as well just keep going. I like to write things. So, I mentioned here that marginal revenue is twice as steep as demand. So the reason behind that is if we think about, we've got a, think about what total revenue is, right? The amount of revenue you make would just be kind of your price times quantity. How much are you selling the good for times how much of that good you're selling, right? But with a monopolist, all right, we can think about, we could insert into price the demand curve, right? Because they're the only firm, they're facing the entire demand curve. So, I could write in a generalized demand curve here, the intercept plus some slope times quantity. And remember, this is still my total revenue. And then, right, inserting my demand equation, because usually our demand equation would look like this. So I'm plugging that in for the price, right? And I could think about here, I've got, if I want to, AQ plus BQ squared. So basically, what a monopolist is trying to do, if we want to kind of relate this into the mathematics, and I'll never make you kind of work through this entire proof, but just to kind of give you a little bit of a look behind the curtains as to why. If I want to find what the optimal quantity is to produce in order to maximize kind of my total revenue here, if I take a derivative of this function in respect to quantity, right, that would give me the additional revenue, right? So I'm thinking about a change in total revenue from a change in quantity, right? That's how I'm going to get my marginal revenue. Total revenue is just how much money I've made. Marginal revenue is the additional amount of revenue made from each increase in quantity. Now, marginal revenue might be very different at different quantities, but if I do this derivative, I can actually determine what marginal revenue is. So marginal revenue is the derivative of total revenue in respect to quantity, right? So if I take that derivative of this function, I've got A plus 2 times BQ, okay? Which basically is the same as our demand curve, but twice as steep, right? And this B is always negative with demand. So, thinking about when I'm saying steep, it's always gonna be downward sloping there. So anytime we're doing with a linear demand curve, that's why we know that the marginal revenue curve will be kind of below it, and also we know it's gonna be twice as steep, okay? As I said, this should be some review, but I want to make sure we kind of go through a little bit here. Any questions on that? All right. Let's go back to the slides here real quick, and then I'll do a little bit more work. So, this is a much longer kind of bullet point slide, but we covered almost most of these points. Bless you. So we've got a single producer, maybe they hold a key resource. Maybe this is the reasoning behind why. Certain sports, you could argue, have kind of monopolized the market with certain media contracts, right? They're the only kind of producer of this good, sporting events of this type that are being sold to these different outlets. Maybe government has rights to exclusive goods. This doesn't really apply to a lot of the situations we're going to talk about. More often than not, there's just some natural monopolies that exist, that there's only so much talent out there that can drive demand high enough for a particular sport. So, anytime we see a sport where there's only kind of one league, it's probably because if we had competing leagues, there's just not high enough demand for those two sports to exist at the same time, right? There might be enough demand for one league, but as soon as you have to split that with another league, demand isn't high enough, right? So we call those natural monopolies, right? There simply is just enough demand to support one of these leagues, okay? We already talked about this, right? The optimal quantity is where marginal cost is equal to marginal revenue. That's always how firms make their decision. And then we also kind of went over why marginal revenue is twice as steep, okay? And I got a nice little visual here. We kind of went through this, on the, I don't know what to call these. It's not a whiteboard. It's on the paper that I'm drawing on, a dot cam. But right, you choose that optimal quantity where marginal revenue is equal to marginal cost. You then, as a monopolist, can charge the price that consumers are willing to pay up here on the demand curve. Oops. And then, we can think about things like, how that would be different as opposed to if this was a competitive market. Well, then we would just be at where supply is equal to demand. Remembering that this marginal cost curve really is a supply curve because there's only one firm. Okay. So here I've got, how would this look if we had a ticket market? Right? So let's say instead of looking at kind of these generalized goods, we're looking at specifically trying to, the ticket market, trying to sell tickets to a certain game, sport, league, whichever one we're interested in. That would all kind of work the same way. So here we've got demand, and we've got a marginal revenue curve that's twice as steep, right? Because they're kind of monopolists. They use this marginal revenue curve to try to determine where they can maximize kind of profits. So we've got marginal revenue here, right? But our marginal cost curve with tickets, remember, runs along the x-axis and then vertical at whatever capacity is. Here I chose capacity being 11,500. Okay? So you can see if we didn't have a monopolist in this situation, this marginal cost curve, we said we really were thinking about that's the supply of tickets. So a perfectly competitive market, we would end up at the point where the demand curve is intersecting the marginal cost or supply curve. So we would still charge a price of kind of $12 here. But notice the quantity would also be the same. Well, look, if demand is high enough, right, what's optimal for this monopolist? Well, where does marginal cost equal marginal revenue? And then charge the price people are willing to pay. So there's actually no difference in this scenario between a monopolist and a perfectly competitive market, in the sense that we still end up with the same quantity, total capacity, and we still end up at the same price. Okay? So kind of nice, there's no real difference there. Now we have to be careful, because what I believe I don't have, what I don't have in the slides. So we'll go to new share. To sell to capacity. Actually, I can do one where even if we were selling at capacity, that's what we actually should do first. So we are looking at, right, quantity of tickets and the price of those tickets. Okay. So let's say we've got capacity is right here, right? So we can think about this as supply, marginal cost, right? Marginal cost is 0 up until we get to capacity, and then it's just kind of straight vertical, right? So let's say we had demand that looks something like this, right? So if this is a perfectly competitive market, the equilibrium price, we'll call this maybe PC, and then Q. So that's the equilibrium price and quantity if we had a perfectly competitive market. However, you can think about marginal revenue is twice as steep as demand. So now if this is a monopolist, right, they're facing this marginal revenue curve, where are they going to determine is the optimal quantity of tickets to sell? They go off the rule where marginal revenue is equal to, I just said it a couple times not too long ago. What were we doing over here? How are we choosing this optimal quantity? It's where marginal revenue was equal to marginal cost, right? So we're doing the same thing here. Where does marginal revenue equal marginal cost? Well, remember, this marginal cost curve runs along this x-axis and then vertical at the point of capacity, right? Right, there's 0 marginal cost because the seats are already there, right? The game's going to be played regardless, right? So we actually end up with the monopolist choosing to sell a lower number of tickets, right? But they know people would be willing to pay at this quantity, whatever point we would be at on the demand curve. So kind of similar effects that we had before. If demand was high enough, we said we saw no difference in the price and the quantity, right? But if demand isn't high enough, potentially we could see this reduction in the quantity of tickets that are provided. So we can think about, for a monopolist, what impacts could occur here? Well, here we saw quantity went down and the price went up, right? In the other scenario, when demand was high enough, we actually saw that neither of these things changed. So we kind of have to have an idea about where the demand curve is at. We have to know, where the marginal revenue curve is at. In this scenario, we would see changes if the market was in fact a monopoly as opposed to kind of perfectly competitive. If we go back to the drawing I had in the slide where demand and marginal revenue were both high enough, well, then we didn't see any changes. Let me think if I want to go through another one here. It might not be that interesting, but we'll go through it just to kind of see. Oh, sorry. Did everybody have everything they needed from here before I keep moving? Okay, that. All right. Make sure everything. Okay. So the other kind of only other situation that we could have is, let's say we start out not selling at capacity. So we've got, I don't know, capacities out here. This kind of represents our supply or marginal cost curve. Let's say demand was right here. This is kind of one of those weird scenarios where we said, well, theoretically, if demand wasn't high enough and marginal cost truly ran along the x-axis, which we mentioned, in practicality, if we're trying to really look at real world scenarios, maybe there's a slight increase, right, in the marginal cost curve here. But for all intents and purposes, it's relatively low. We then have the kind of marginal revenue curve here. Well, a perfectly competitive market would end up right here, right? So the perfectly competitive market, demand is equal to supply right there, right? So we can kind of think about, here's my perfectly competitive quantity, and the perfectly competitive price in that situation would be 0. So this is where last class I mentioned, look, if this was a perfectly competitive market, why do we see stadiums that are sold under capacity, but the prices are still non-zero, right? They're still well above 0. Well, the reason why is because if I don't have enough demand to meet capacity, as a monopolist, I'm actually making my decision based off of where this marginal revenue is equal to the marginal cost curve. And so I would actually choose this point, right? So we can kind of think about here is the quantity the monopolist would choose, but they know people would be willing to pay whatever price is up here. So once again, kind of the same outcome is that if demand isn't high enough to kind of sell out the stadium, a monopolist relative to a perfectly competitive market, we're going to see, right, lower quantities and higher prices once again, right? So when demand is not incredibly high, right, we're going to see your typical effects of a market having being monopolized, right? That quantities will be lower and prices will be higher. The only scenario in which we might not see that is just because, if I can get this to be up here real quick, is because demand was high enough, or you can think about demand was high enough and capacity was low enough that even with a monopoly in that market, we still end up kind of selling to capacity and at that same price wherever the demand is equal to the marginal cost of the supply curve. Okay. Any questions on this? So here's like an interesting scenario. So if we're in this scenario, right? Ideally, if I pushed my marginal, if I could increase the capacity in my stadium, as a monopolist, there's still, if I could increase capacity, say, to out here, right? Then the marginal cost for these tickets would be 0. My marginal revenue is greater, so I'd continue to sell more tickets. So if I could somehow increase capacity here, you actually could end up at a scenario where eventually we get to capacity being out here, and the monopolist is actually purposely like not selling out to capacity, right? Because they would, once capacity gets past where marginal revenue hits that x-axis, well, that x-axis becomes where the monopolist is going to choose, right? That's would be where marginal cost is equal to marginal revenue. So you theoretically would want to, if you were a monopolist, increase capacity out to the point exactly where that marginal revenue is equal to the marginal cost on that x-axis. Because if you continue to push it out any further, that's not going to alter your decision, and likely to increase your capacity, you have huge fixed costs, right? So if we're thinking about more of a long run scenario, if demand really was this high relative to your capacity, you'd want to try to start increasing your capacity, out a ways to increase kind of profits there. But that's kind of a long run. That's kind of more of a meta kind of thing. So Any questions before we kind of move on from this a little bit? This idea of the ticket market. Okay. All right. So we're thinking about kind of profit maximization, right? What if we have, we're talking about providing, a certain number of tickets for one particular game, right? But we can think about what would happen if there was differences kind of across these games, right? We're not going to face the exact same demand curve for every single game that we're trying to sell tickets to, even if we're looking at the same team, right? Within the same year even. So when you think about what's going to happen if we have lower demand for one game, right? We kind of went through some of this a little bit last class where we see decreases in the demand curve, depending on where we were at, like if we were selling out or not, right? We could see, we see prices fall. The number of tickets we said could fall, but if demand didn't decrease by very much, we still could continue to kind of sell out the game. So I think we went through some of those changes last class. But, right, we can also think, one thing I know we didn't do is we can think about what happens if we increase the size of our stadium, right? So I kind of already mentioned how this is optimal for a monopolist, but we'll review here in just a second exactly what would happen if we increase capacity, right? So our supply curve would shift out. Our supply curve here was just a vertical line, right? We might see ticket prices fall. We will see ticket prices fall and the number of tickets increase, but potentially we don't sell out this new stadium capacity. So I'll draw you a scenario there. We start to think about questions we might have talked about last class as well. You start to think about, well, what if I restructure, players' contracts and I try to reduce costs? The costs of running the team aren't factored into the marginal cost of providing the ticket. When we're thinking about the ticket market, we're very specifically thinking about ticket revenue, right? And the costs specific to providing those tickets. There are many other costs that the organization has to think about, but in terms of the cost of providing those seats, right, that's just going to be, things like heating and cooling the building, or any type of cost we're going to pay there. It's just to have the building functional and to actually build it. But once we build it, those are all fixed costs, right? Those costs don't change. Maybe the heating costs change incrementally the more people you have in the stadium, but it's pretty insignificant there. Okay? So our marginal costs really aren't impacted by any of these. The marginal costs of providing the tickets aren't influenced by the costs of the rest of the costs that the teams face. Right? So let's go out here for a second. I know I can switch there, but I always don't see it. So typical ticket market. So we've got our X and our Y axis, quantity of tickets, price of tickets, right? Let's say I've got my capacity is somewhere like right here, okay? And then I've got, how do I want to draw this? Can I make this kind of interesting? So we'll go, here's my demand curve, here's my marginal revenue curve, there's my supply curve. Okay? So the monopolist chooses the optimal quantity, where marginal cost is equal to marginal revenue, and then goes up to that demand curve to determine what that equilibrium price is, right? So maybe we call this S1 for kind of stadium one's capacity. Right? I then think about, okay, well, what if this firm increased its capacity, right? So I'll show you where we might not sell it out. So even if we build a new stadium, if we aren't, let's say we tried to evaluate where the demand curve was at, we were a little bit off and we thought it was a little bit higher. So we kind of overshot, and let's say, I think about here, I should have left myself a little more room. Right, this is I could actually write up here, right? This is the second stadium's capacity, S2, or you could write stadium 2 capacity. You could write the whole thing out if you wanted. So where are they going to make the optimal quantity decision? Well, their marginal cost, right, now runs along the x-axis all the way up to this point. So we could call this like the second supply curve, second stadium capacity. So they're going to choose the optimal quantity to be here. We could think about in the first scenario, the stadium capacity was actually the equilibrium quantity. So now, building this new stadium, they are selling more tickets, but they're not selling out the entire stadium. The price that they're going to charge, right? If I can get this drawn correctly, right, is going to be a little bit lower. Like, no matter what change we see here, we could draw this however we wanted. We're always going to see that the new price after having this larger stadium is going to be lower. But, you know, if you think about, as long as that dip in the price is less than the increase in the number of tickets I sold, I've actually increased my total revenue there, right? Just thinking about total revenue being price times quantity, right? So, you know, we could think about all, you know, really, they might be faced with all these different stadium capacity options, right? And when they're building that stadium, they're likely thinking about, okay, how much more additional revenue can I earn in the ticket market? And if that is greater than the stadium costs over, you know, a certain period of time, then it makes sense to build to that capacity, or build a stadium of that capacity size. But that's kind of a you know, decision being made separate outside of this model. We're here just trying to analyze, well, what would happen if capacity changed? Okay. Any questions on that? So yeah, we can think about demand shifts. We can think about here supply shifts are really capacity shifts. But hopefully, I mean, we've kind of hammered this quite a bit now, but this is hopefully a good understanding of the ticket market, right? And things that could change in that ticket market. And, you know, those things may depend on how high demand is, right? So unless you're given more information about exactly, you know, were they selling at capacity or under capacity before? Was marginal revenue, you know, below, kind of intersecting the x-axis below capacity? You would need to know some of those factors to determine exactly what a demand or a capacity shift would do here. The capacity being a supply shift. Okay. Any questions on that? No? All right. So let's go back here. This is where we'll start to have this discussion about, you know, revisit what we talked about last class, which is we talked about there's this increasing marginal cost to win games, right? That the product is winning, it has increasing marginal costs, okay? So for a traditional company, right, if we wanted to maximize profits, what we're going to think about is I'm trying to maximize the kind of difference between my marginal revenue and my marginal cost, right? Now, teams, right, they might want to maximize profits, but they also may have an ulterior motive, right? They also may want to win games, even if it means slightly lower profits, right? So really you could think about teams kind of have an indifference curve, and we could really complicate this in saying every team has some mix of what weight they put on winning and what weight they put on profits. Now, we're going to go through it as though those weights are just 1 or 0. So either a team completely is just trying to win maximize, or a team is completely trying to profit maximize. But you could actually complicate this even further and think about, well, what if there was kind of like a weighting of the two? Some teams value them both 50-50. Other teams value winning 90% and profits only 10%. Right? We could do a whole bunch of different combinations. But for right now, we're just thinking about teams that either are trying to solely put their efforts into winning or solely put their efforts into profit maximizing. Okay? I get that. There you go. So there's a trade-off between the two, right? Because as eventually we get to a point where if I want to win additional games, right, we said the marginal cost of a win is increasing, right? Because initially, by adding units of talent, I can increase my number of wins at a pretty high amount. But eventually, once I've got, like we use NFL football, if I have 15 wins, it's going to cost me a lot of money to go out and get enough talent units, right, to increase to that 16th win. Because the marginal kind of production of talent, right, we said was relatively lower. The number of additional wins that units of talent bring in starts to kind of decrease and get closer to 0 as we add more and more units of talent. So if I want to win that 16th game, I have to spend a ton of money to the point where I might be getting less back from those units of talent or those players than what I'm spending on them, okay? So there's a trade-off between the two, right? And we can write this out a little bit more kind of mathematical here, where the cost that a team faces kind of is a function of how many wins it's trying to target, right? So, you know, if I only want to win 2 games in the NFL, I probably don't have to spend near as much money as if I want to try to win 14 or 15 games, right? And then kind of specifically here thinking about kind of that I'm spending on talent. Right? We're also going to have some function where revenue is also a function of wins, right? I'm guessing teams, you know, that win 2 games, they're not going to, you know, have near the ticket revenue as teams that are kind of winning 14 or 15 games or in the playoff hunt. And so we know that revenues are a function of wins and costs are also a function of wins, right? So if I'm trying to target, and other functions maybe of some other things as well, but here I'm trying to choose kind of the optimal number of wins that I want to target from my team. So the only thing, you know, what I'm choosing is what's going to be kind of changing the revenues and costs here, the kind of optimal number of wins. Now, oops. If I rewrite this, I can think about my profits that are coming from this decision about what, you know, how many games I'm winning is really the difference between the revenues and the costs, right? My total revenue minus my total cost, that's my profits. Okay? So I want to try to choose this number of wins such that I've maximized total profits, right? Well, if I take a derivative of this function, right, what I'm really thinking about is, at what point will I be, you know, if I continue to win games, at what point will winning another game not increase my profits? Or at what point will winning another game, the difference between the revenue and the costs actually become negative? Or I'm actually spending more money to win that additional game than I am bringing in additional revenue, okay? So really, mathematically, what we're saying is, at what point does the change in profits from a change in the number of wins become 0 and then consequently negative, right? So for now, let's keep that marginal cost of a win constant, okay? So this makes it a little bit easier for the analysis that we're going to do. If it was increasing, which it more than likely is in practice, that's okay. It would just complicate things a little bit, right? But for right now, we're just going to think about this marginal cost of a win is constant, right? So at any number of wins, the cost is constant. We know that revenue is generated from fans. I kind of already mentioned that, you know, revenue is driven from wins. You know, but potentially, and I used baseball, I think here, you know, the revenue gained from 10 additional wins. Well, if I go from 70 to 80, that might change kind of how people view my team a lot more than if I go from 95 to 105 wins, because they're winning an additional 10 games, right? I'm still probably in like the same kind of playoff hunt picture. Or if you want to put this in the context of, we do football, right? Going from 1 to 2 wins probably isn't going to bring in a whole lot of additional revenue that season, as opposed to where if I go from, I don't know, or sorry, how do I say this? Going from, I'll give another example, going from 9 to 10 wins, right, kind of puts me in the same kind of tier, or, you know, I'm in the playoff hunt, but probably not more than likely a Super Bowl contender. So if it pushes me into the playoffs, maybe that win can bring in a lot of additional revenue as opposed to going from 15 to 16 wins, because there, nothing has changed about my circumstance. I'm probably still like number 1 in the league. And so we can imagine we likely, just with many other things, have this decreasing marginal revenue curve, right? As we win more games, the additional revenue kind of decreases. Right? So what we're trying to do is target a number of wins where that marginal revenue is equal to that, the marginal cost of a win is equal to the marginal revenue of a win. And we're going to treat the marginal kind of cost as constant for right now. Okay. So I think I have a quick graph here, but let's go to, what do I want to do here? Let's go. That's a good graph for if someone's kind of going back through and wasn't here in class, but I want to build that a little bit. So, I got to get used to selecting this. I'm used to going to a All right, that helped us understand kind of the revenue coming from the ticket market, but we don't just generate revenue from tickets. We generate it from apparel sales. We generate it from kind of selling games to different media outlets to kind of, ABC, CBS, televise the games. So if we're thinking about what's the kind of optimal number of wins, right? So our quantity here is wins, right? There is a point at which it just becomes very costly to win more games, and it wouldn't be good if I'm a profit maximizing team, okay? So we said for simplicity, let's keep our marginal cost curve constant, right? Every additional win, we know this likely isn't the case, but we're just going to assume it's constant, right? Just to get first idea about what's going on here. We then could think about, we're going to face some demand curve. Every team will have a slightly different one potentially, but every team is going to face a demand curve for whether or not they win. Okay? Kind of think about, they are a monopolist here, right? They're the only team providing wins for their team, and so maybe we think about, we've got this. I shouldn't say maybe. We've got this demand curve, and so with a monopoly for providing a number of wins for that specific team, that team's the only one that can do it, they're going to face this twice as steep marginal revenue curve. So we'll keep demand linear here. The only thing that it would do, if it wasn't, it's just complicate the math a little bit. Okay? So if I'm purely a profit maximizing team, right, and these reflect the marginal revenue and the marginal cost of providing additional wins, I will want to continue to win as long as the additional revenue is greater than the additional costs. Because if the additional revenue is greater than the additional costs, I'm increasing my profit, right? I've spent less than I'm generating. So I'll do that up to the point where those two things are equal, because past that point, well, like let's say here, I don't know, I'll put some numbers to it. Let's say this was 7 games. If I want to win that 8th game, the marginal revenue or the additional revenue that I would generate is less than the additional cost, so I've actually just decreased profits from that point. Okay? So they stop here, right? We could kind of call this maybe, we could even put a little thing to note, hey, this is the kind of equilibrium or the optimal number of wins for a profit maximizing team. Okay? Now, if a team wants to win maximize, right? What would they do here? Well, if a team wants to win maximize, when they go to that 8th game, they see that the marginal revenue is less than the marginal cost. They don't care. They don't care if they decrease profits as long as they have enough money to spend to win an additional game, right? So they continue to spend money even though marginal revenue is way below marginal costs, right? Up to the point where that demand curve kind of intersects that marginal cost curve. Right? So here we would say the win maximizing point for a team that wants to, the optimal wins for a team that wants to win maximize would kind of be this point out where the demand curve is equal to my marginal cost curve. So the reason why I did this simplified model where we have constant marginal costs is because if we think about here, if I've got kind of total revenue, I'm going to rewrite that as price times quantity. But I can really think about price, remember, is my demand curve. Okay? So if profits are total revenue minus total costs, I've got my total revenue equation. Total costs here would just be the quantity I'm selling. Because the marginal costs are constant, just the quantity times that constant cost. So it makes it a little bit easier when we go down here, right? Think about, we have our demand equation times quantity minus that cost, I guess, times quantity. I'll kind of rearrange that a little bit. Okay. So if we kind of move this out to the side, this quantity, wherever the demand curve is minus that cost times the quantity, the point at which demand is equal to that cost, right, where the point that I'm on the demand curve is equal to that cost, that's where, well, if they're the same thing, 0 times any quantity is 0. So this is essentially the point. We want to think about why we have to stop there as a win maximizing team. That's where profits equal 0, right? So we're looking at this as a long run decision where, you know, potentially year to year, maybe they could continue to push out past that point. But if we're drawing this in the long run, a team can't operate with negative profits year after year. At some point, right, they're going to have to earn some positive profits. Yeah. Oh, sorry. There we go. Now, you could make some arguments here outside this model that you could complicate it. Like, what if they can borrow money from other companies they own? It's a slightly separate issue than this, right? We're thinking about if this is a self-contained organization, right? They can't operate with negative profits in the long run. So a win maximizing team kind of pushes out to this point where the demand curve is equal to that constant marginal cost. Okay? And like I said, if we didn't have constant marginal cost, it would complicate this a little bit, but this really the same implications would occur, right? You would end up kind of pushing out to the point, if you're win maximizing, out to where profits are equal to 0. Okay? Any questions on that? You know, this makes it a little bit easier if we wanted to think about, I think just to mention something, because I know I have it in the slide. Another way we can think about this is demand is kind of representing our average total revenue here. You know, if you think about, I have demand times quantity. To get the average of something, so average total revenue is just total revenue divided by the quantity. Well, if my total revenue is the demand curve times quantity, and I'm dividing that by quantity, my average total revenue is the demand curve. Oh, I don't know what I just did there, but so that's one thing that I know I put in the slide. That's not overly important to the kind of conversation here. What is important is we realize when maximizing teams, profit maximizing teams, it's still pretty easy. We're identifying where that optimal wins are by based off of the marginal cost and the marginal revenue, where those two things intersect, right? Because that's where profits are maximized. Past that, if we want to go past that point and win maximize, we'll continue to push out, eating into our profits along the entire way up into that optimal win number where profits would be equal to 0. And then that's where I would stop, okay? So just to kind of get a little more discussion here. Not every team is going to face the same demand curve. Remember I mentioned that. So how could you use this model? Let's say all teams are win maximizing. What types of teams, and this could apply to any, think about whatever sport you have the most knowledge on, or whatever, you think some league exists. What do you think, what teams do you think, if everyone was win maximizing, what teams would you expect to be able to target the highest number of wins? Because they all face different demand curves, right? They'll all go to the point where profits are equal to 0, but they'll all face different demand curves. So what are some things that might help influence the demand curve that would benefit teams of a certain type? Yeah. Market size, right? So market size is a combination of things. One, population. That's how we generally think about it. If there's just New York City is going to have way more people, increase the demand curve, right? More consumers. We would expect the population is a huge driver of that demand curve. But not only do you have to have people who, it's not just the willingness to pay that drives demand, it's the ability to pay, right? So I need more people, but I also need, higher income values as well. So when you think about these really large cities like New York City, LA, they have usually both of those things, right? They have a lot of people who have a lot of means to be able to go kind of purchase ticket or spend money on your team. It doesn't just have to be tickets. It could be through apparel and other things. So if I have large versus small market teams, I'll start using that terminology a lot. Large market teams, you think about New York, LA, Chicago, huge populations, lots of high income individuals. Smaller market teams, generally we think of these like, I don't know, Charlotte, Jacksonville, Indianapolis is a pretty small market team if you compare it to other large cities. So if this is Indianapolis, they might only be able to target this number of wins, even if they're win maximizing, they don't care about profits. What about if we had New York, their demand curve is way out here. You know, you can imagine the point I can't even draw it, I do it too far out here, right? Their win maximizing point might be way out here. So automatically, if we believe that a lot of teams are win maximizing, this already starts to highlight why we're going to see differences between small and large market teams, right? Because the demand curve they face is so much higher that if they're both win maximizing, the large markets will always have a higher number of kind of wins they can target there. Now, all of this too, so we don't get confused, every team wants to win every game, right? But we're talking about the resources that they put behind that, because just because they want to win the game doesn't mean their, you know, decision-making is actually providing that team the ability to win more games. So it's kind of like, given the resources that teams have used, what number of wins have they targeted? It might go one way or the other, right? You know, anything can happen in a lot of these sporting events. But, you know, if I construct a team and I'm spending, you know, however we quantify it, I'm arguably have the lowest units of talent in the league, I'm not going to have the highest number of wins that year, right? So we are talking about kind of not the realization of wins, but what the kind of targeted number of wins based off the talent that they've built going into that season is. Okay. Kind of like, you know, if you're I always compare this to like anything where you don't know what the outcome is going to be. So even if this is like investing in stocks, right? I probably invested in stocks based off of some historical performance that I targeted a certain return. Well, things happen you don't plan on. By the time you actually, you know, sell those stocks, your return might be lower than that targeted amount. It's the same kind of idea here. It's the number of targeted wins, right? All right. Any questions on that before we keep going? Okay with that? There's another way you can think about this as well. Instead of kind of analyzing this through the marginal cost and marginal revenue, which I think that's arguably the best way to think about this. If I'm trying to determine where my optimal number of wins is on this graph, which instead of showing my marginal cost and marginal revenue, shows my kind of total revenue. And then because we kept cost constant, my total cost kind of curve here is linear. Well, the difference between total cost and total revenue, right, that's where profits would be highest. Profits are simply total revenue minus total costs. So if we looked at the difference between these two lines, total revenue and total cost, wherever the greatest gap is, that's where profits are highest. So, you know, if I'm thinking about this graph, profit maximizing teams would be somewhere like right here. It's a little bit harder to see visually. That's why I don't think it's as good of a graph to kind of help us remember what's going on. And then the point where total cost is equal to total revenue, well, that's where profits are, 0, right? So if we wanted to identify the win maximizing kind of number of wins here, it's going to be where total cost and total revenue intersect. Okay. But generally, we'll analyze things through this graph because decisions really are made based on the margin, right? And we can identify, you know, where those points would be at in this graph, but it's a little bit more clear when we're looking at the marginal cost and marginal revenues. Where are we at on time here? 4:24. Okay. All right. So we already talked about this, kind of already worked through it. We can think about just some differences that we might see. So here I had, I think this was Major League, yeah, it must be Major League Baseball, right? Looking at the number of wins. So you've got team revenue kind of amounts, and then you have the number of wins. So all I did here was grab from last year the number of wins and the team revenue for every single baseball team in the Major League Baseball, and then plotted each one of those as a, you know, XY combination, right? I took the team's revenue, their number of wins, and plotted that point. And then did a line of best fit, right? So when we talk about linear regression, this is where we're really thinking about, in the simplest form, we're trying to come up with this line of best fit, right? We have all this data. We try to find this line of best fit between these two variables. And then the slope of this line tells me something about the relationship between my X and Y variable. So here, the slope of this line would tell me the additional number of wins that comes from an additional, amount of revenue, right? However much I'm increasing revenue, okay? Or really a 1 unit increase in revenue is likely. I think the way this is measured, it looks like it was measured in dollars. So a $1 increase would increase the number of wins by whatever the slope of this line is. Right? So we look a bit at costs and things as well. So you kind of see here when teams are earning more revenue, they're winning more games. As teams win more games, they also have higher costs, right? The relationship between most of those things is positive, which makes sense, right? If I win more games, I can bring in more money, but to win more games, I have to increase my costs. So some of this discussion that we've had, this is really just kind of some data that supports it, right? Just some interesting numbers, and I think we'll probably transition here to the papers I wanted you to read in a little bit. But I do want to kind of just look at some of the numbers that exist for these revenues and these costs that we're talking about. So I typically will kind of grab numbers from the 4 biggest kind of leagues: NFL, MLB, NBA, and NHL, right? So this is Forbes valuations. In 2016, the Cowboys were valued at $4.2 billion. Patriots at 3.4. You can kind of see some of these different numbers. I mean, this is a lot of money that these teams are valued at. These are only 3 of the 30 teams in these leagues. Now, if we look at this, we'll go to 2017. It's usually the same teams. I think sometimes 1 or 2, one of the third place teams might, switch with the fourth. For the most part, it's the same teams at the top of the leagues. But notice the valuations. So 4.2, 3.4, 3, and 1.25. They've all increased here, right? We go to 2019, I skipped 2018. Notice they've increased a lot more, right? So all the valuations of these top teams in these leagues have just continued to increase throughout time. We're talking about pretty large dollar amounts, right? What's something else if we look at these teams, and they're probably, kind of the Cowboys are probably the biggest exception that we have here, but especially across these 3 leagues, if we exclude hockey, just because there's a lot more Canadian locations there. What are true about these cities that we typically see? So some of the top teams in the NFL, got New England and New York, so Boston and New York, LA, Boston, New York, LA. Golden State's kind of a weird one. I forget where are they actually located now? I thought they built another, or were slightly, I thought it was an area not technically Oakland, but same idea. Someone else has got it for me. Is it Oakland? San Francisco. Yeah, I knew that. So they were, and now they're in San Francisco is huge, kind of close to Silicon Valley. You've got a lot of money there. But all these cities, regardless, even Dallas, right? Even Toronto, they're large metropolitan areas, right? So these, teams that we see that are valued the highest are also likely going to be the teams that are from these large market areas, right? I think we'll kind of revisit this. We'll revisit some of the differences in kind of costs and kind of profits here next week, and then we'll break down. So a lot of times, like this week is a very good example. I threw 70 slides on here because I wasn't sure exactly how quickly we move through things, what we would talk about. I just want to have everything kind of ready to go. So next week, we'll break down different types of revenues, a little bit more detail. We'll probably revisit that ticket market a little bit as well. Just thinking about what happens if we see different combinations of small and large market teams. But I did want to talk about here for the last 15 minutes, these 2 papers, and kind of do a little bit with linear regression, right? So just kind of a review, right? When we're doing linear regression, I already set this up a little bit, but in a simple linear regression, the easiest way to think about this is I have this scatter plot of data, and I'm trying to fit this line that goes through the data perfectly. So there we go. So if I have this scatter plot and I have this line that best fits the data, right? I believe in one of the papers we'll be looking at here, they were thinking about kind of draft order and then playing time. So in the most simplistic form, what I'm trying to do is using all of the data that I have on draft order and playing time, find a line that best fits that. So this line we could think about as we've got playing time. There's going to be some intercept value A and some slope on that variable draft order. So the way that we can interpret this is, well, this is the slope of this line. If we were to go up by 1 unit, so let's say go from 20 to 21, B, or that slope, is how much that Y value would increase. And in this case, it's increased because I have a positive relationship. If we had a downward sloping line, it'd be how much it decreases from a 1 unit change in that X variable, right? So when I use Excel to run this linear regression, the interpretation of this slope coefficient will be, if my draft order were to go up by 1 unit, this slope coefficient that Excel will give us a number for is how much the predicted playing time would change in that following year, okay? Now, here it's a little bit tricky. Sometimes we have these regressions that get a little bit tricky. So if I think about draft order, right, what would you expect the sign of this to actually be? So if my draft order goes up, I'm not the first pick, but I'm the second pick. Or I'm not the second, but I'm the third. What is likely true about the playing time for those players the next year? Well, likely they were taken higher in the draft because they're better players, so they'll probably see more playing time, right? So as my draft order goes up, that's actually a bad thing, right? I'm actually becoming like a worse quality player because I'm being drafted later. So we probably don't think we're going to see this. It's probably going to be negative, but this gets at kind of the idea of what we're doing with linear regression. Let me see here. Okay. So kind of already have alluded to this a little bit, but if one of the papers focuses on what's the effect of being drafted later on playing time, or I think the NFL paper, what was that? It was not draft order, but did anybody read it? Look through it? What was the NFL paper looking at? Not draft order, but anybody take a look at them? Well, these discussions aren't as fun if you don't look at it all. So the NFL paper wasn't looking at draft position, but they were instead looking at how much money is that player's salary worth or contract worth, right? So the idea being that if I have a larger contract, yeah, I might be of higher quality, but teams could also kind of hang on and give me more chances. So I might see increased number of starts or increased playing time if they gave me a larger contract, okay? Now, if we just try to run these simple linear regressions, it's really hard to parse out whether or not teams are kind of going through this thought process, right? And if they are going through this thought process, they shouldn't be evaluating how many starts or how much playing time a player gets based off of where they were drafted or how much money they're currently paying them, because they should be making decisions on the margin. That money's already been spent. That draft pick's already been used, right? Those are sunk costs, and they shouldn't be factoring into our decision-making now, right? So if I'm able to observe how the player is currently playing, what their quality is, my decision shouldn't be based off of how much I have already paid them, that sunk cost. It's how much revenue are they going to earn for me moving forward, right? So if they're not playing well, even if I paid them a boatload of money, I shouldn't continue to play them, right? And, you hear commentators all the time talk to these things, and then a lot of, well, they're sticking with him because they got this huge contract. Well, if they're playing bad enough, if the quality of that player is low enough that you can replace them with a higher quality player, that's what you should be doing optimally, right? So really what these two papers get at is whether or not teams fall victim to this sunk cost fallacy. I've already used the draft pick. I've already guaranteed this salary. I shouldn't be factoring that into my decision moving forward, okay? Now the problem becomes, we'll have the summary here, but we'll actually look at the paper. Use the NFL one first. So the problem becomes is, well, yeah, if I gave someone a lot of money, right, that's probably, where do I want to go? I don't want to show you this before I start talking. Where's the regression equation? Here I'm going, we'll come back to this in a second. So, you know, if I already gave them a bunch of money, it was likely because they were a high quality player, right? So if I don't control for how good the player is, and I just look at the kind of relationship between draft order and playing time like I did there, I've got a lot of really important variables that I'm leaving out of the discussion, right? And those variables are likely kind of correlated with both playing time and draft order. And we probably won't have as long of a discussion today about omitted variable bias, but basically, if we leave out variables that are important to predicting our left-hand side or our Y variable, our results really aren't going to mean anything. So we want to try to control for as many things as possible. So what this paper is attempting to do, and actually, sometimes I'll look for the regression equation here. Theirs aren't written out quite as clean. But what they're really trying to get at is how many games, right? If we look at this linear regression equation, they're looking at wage, how much the player is being paid, holding constant a bunch of other X variables, and trying to determine what this beta is. So usually when I write that down, I write it as B, but in a lot of these academic papers, we'll see it written as beta. So if the player's wage goes up, right, what is the impact that it has on the number of games they play in the future, right, or kind of the following season? Holding constant a bunch of other factors. So the factors they try to hold constant, we'll scroll down here and look at, what is this, table 5, right? And you don't have to be too concerned about kind of what's going on up here for right now. It's something that's probably outside the scope a little bit of this class. But we can think about this as, here's kind of how much of that salary goes against the cap. So like that money's already been spent, right? If that player's salary or that cap value of that player is higher, we expect them to start a higher number of games, 2 additional games as a matter of fact. Now we've held constant a lot of other things. So they kind of put down here where the player was chosen, the player's experience level. They put whether or not they were undrafted, different positions. Notice here, they don't show you everything they included. I think if you read the paper pretty detailed, they include for that player's performance, right, player statistics. They also include the team's performance statistics. So different measures of, you know, how many receiving, rushing yards the team had. Also, how many rushing, receiving, passing, whatever yards the player had. So they had year effects. They had what team the person was on. They've tried to control for everything. So then the interpretation becomes, if the salary of the player goes up by 1 unit, and here they did some other goofy stuff that we're going to kind of gloss over, but if it goes up by 1 unit, here's the change in the expected number of starts, holding everything else constant, right? So a 1 unit increase in this X variable causes the predicted Y variable of number of starts to go up by this amount, holding all these other variables we included on that right-hand side constant. So the thought experiment here is, if I had 2 players, what on here, both playing for the same team in the same year, because of inflation, things like that, their teams performed exactly the same on all these different statistics we had. The players performed exactly the same in all these different measures that we have. They both played, you know, the same position. They were both either undrafted or both taken in whatever the same round was. If all that was the same, but one of them had a 1 unit higher contract that went against the cap, how much more or less, how many more or fewer games could they expect to start? And that would be kind of the interpretation of our coefficient. So when we include a lot of these control variables on the right-hand side, you know, we're never able to actually observe that scenario where we have 2 players that are identical on every measure, except one of them has a slightly higher salary. We're usually not able to observe that. But the power of linear regression is that we have so much variation in our data that when we run this regression, the coefficient is able to account for all of the variation that exists in every other variable that we included, and we're solely picking up the correlation between cap value and number of games started. We're not picking up the variation that exists from any of these other things, right? And so that makes that result a lot more useful. Okay. Any questions on any of the things I mentioned with regression here, or kind of what's going on in this table? Like I said, this paper had a couple things that were a little bit outside the scope of what I would like to talk about right now, but I think it's still useful in that we can start to think about how crazy it is, especially with sports data. You can control for so much that you have otherwise two identical players. One makes a little bit more, in their contract. It shouldn't matter. They're both the same quality player based off all the other statistics, but teams still appear to be falling victim to that sunk cost fallacy. Right? If I've got more money into that player, then I a little more committed to them. Okay. So generally, when we're looking through these papers, like I said, I'd read the intro. I want you guys to read the intro inclusion just to get an idea about what they're looking at. I then always try to scroll down to kind of find their regression equation. And then I scroll down to kind of look at what those table results are, right? It tells you what the dependent or the Y variable is here, and then kind of lists all your X variables, okay? I do want to briefly mention the NBA paper. It was kind of looking at draft order and playing time. It kind of finds that there wasn't a sunk cost when it came to playing time in the NBA versus when a player was taken in the draft. And they kind of did this like really neat thing where they looked at players who were right on one side of round one. So like the players taken 30th in round one versus the players taken like first or second in round two. Kind of saying there's really not a huge difference in those players, but because one was taken in round one, are they more likely to kind of stick with that player? And what they found is that doesn't exist in the NBA, at least in terms of the draft order. I would think, I'm not overly surprised that money can kind of drive some sunk costs here in the NFL, whereas draft order, you might not think about it as much as when you're looking at those books and seeing how much money that player is actually costing you. But one thing I do want to mention with across all the papers we're going to look at this semester, what we need to start thinking about is, even though we're obtaining these estimates for the coefficient or the relationship between that X and Y variable, here the number of starts and then their kind of contract cap amount, we can, let me see if we have, where's one here? So here I've got the relationship between being a defensive back and playing time. Notice there is a positive value here. However, we can come up with an estimate, and it's only from sample data, okay? So if it's coming from sample data, we can't say that there's necessarily a significant relationship, right? Based off the data, we found some evidence that these are correlated, but I can't say that it's correlated with number of games started with 90% confidence or 95% confidence. So one of the things that you should have hopefully learned in your 221 courses is how we determine if something is significant or not, all right? So we have these different significance levels, and kind of our benchmark values are 1, 5, and 10%, right? Or said differently, can I say things with 90, 95, and 99% confidence? Okay? So when we think about these different significance levels, in these academic papers, if something is significant at I don't think we have a 1 star here. If there was only 1 star next to one of these estimates, what that's saying is that's significant at the 10% level, right? Or that you could say that relationship exists with 90% confidence. If you see 2 stars, that means that coefficient estimate is significant at the 95% level. Okay? Or sorry, significant at the 5% level, or you could say it with 95% confidence. If you see 3 stars next to the estimate, it is significant at the 1% significance level, or you can say that it has a relationship with the dependent variable with 99% confidence. Okay? And we'll dive into a little bit more next week is why that is. It's based off of things like p-values, which we don't always see presented in these papers. But when you're looking at the results, if you do see something, you're like, oh, no, yeah, there is a positive relationship between games started and just being a defensive back. Well, no, there's no stars. So what we would say is that, yeah, we came up with a number for that slope coefficient, but it's not significant. It's not statistically significant. We can't say it's any different than 0. The only time we can say that a relationship between two variables is anything different from 0 is if it is significant or we see those stars next to it, okay? And depending on the discipline, sometimes you'll look at this and instead of stars, they'll use like the weird, I don't know, it's like a line that has 2 lines through it. Not a pound, not like a pound sign, but like 1 line with 2 lines through it. So sometimes we'll see some different stuff there. If they use anything other than stars, they'll usually put it down here as like a footnote. See how this reminds us, 1 star is the 10% significance level, 2 stars is 5, 3 stars is 1. Okay? So I've went a minute over time, so you guys should be ready to get out of here, right? So I'll put up an online quiz when I get back to my office. That'll be due before we meet on class on Tuesday. Other than that, if you have any questions, please feel free to email me. I'll likely have that first homework ready to go on Tuesday, so that'll be posted following class on Tuesday. You can start to work through that because I think we'll be through enough material to where it makes sense to give that to you guys then, okay? And if I haven't emailed you back, I've got a couple of project ideas. I will get you an email back, hopefully when I go back to my office, if not sometime tomorrow, okay? All right, we'll see you guys on Tuesday.